Hey, I'm Ben, and today I'm going to be going over conic sections. More specifically, this one right here. So what we're dealing with is negative 2y squared minus x plus 12y minus 3 equals 4y. It's a lot to say. But anyway, the first thing we want to do is go ahead and we kind of want to examine and see what's going on here. First thing I noticed is the y squared, which we've only got one variable which is squared. So right there that tells me we're dealing with a parabola. Second thing I noticed is that the y value, or the y, is squared and not the x. Had the x been squared, it'd be a vertical parabola, but it's not. So the y value is the only one that's squared, and that right there tells me it's a horizontal parabola. It would be a vertical one if the x value was squared. If there were two squared variables in here, it wouldn't even be a parabola. Anyway, with that being said, we know we're dealing with a horizontal parabola before we even started. So the next thing we want to do is we want to go ahead and complete the square, and to do that we need to get this written in standard form. So that's what it's supposed to look like. This is the equation for a horizontal parabola written in vertex form. As you can see, we don't have it in vertex form, and to do that we need to get it in, or we need to complete the square. So let's go ahead and start working towards that. The first thing I'm going to do is I'm going to go ahead and rewrite this. I want the 4y on this side, and I want all of this stuff here on the right side. So all I'm doing is just flipping the sides. I'm not changing any values or any of that stuff. So there we go. I rewrote it, and I've got 4y on the left side where I wanted it, because personally I like the smaller end on the left side, like we have here. So first thing I'm going to do, and this is what I'm going to do in one step, I'm going to add x to both sides. I'm going to add x here and add x here, and I'm also going to subtract 4y from both sides. The reason why I'm doing that is because I want to move this x over here and move this 4y over here. So to do that, I need to add x to both sides and subtract 4y from both sides. This is what it looks like when we're done with that. With that step, it looks like this. X equals negative 2y squared plus 8y minus 3. We subtracted 4y again and got 8y. We added x to both sides, which canceled out that x, and added an x right here. So the next thing we want to do is we want to go ahead and factor. We've got a negative 2 that can be factored out of these two right here. And so that's what it's going to look like when we factor out the negative 2. We've got negative 2 multiplied by y squared minus 4y, and then subtracting 3 from that value. So that's getting close to where we want to be, but as you can see, we don't have a perfect square yet. And to do that, we're going to kind of need to do a little bit of manipulation, or whatever you want to call it. And so what I need to do is, with this negative 4 right here, I need to divide that by 2 and then square it. So negative 4 divided by 2 gives us negative 2. And then squaring negative 2 gives us a positive 4. So what that does for us, that allows us to get a perfect square trinomial. Right here in parentheses, we have a perfect square trinomial. And we got to remember that that positive 4 that I put in here, it's technically a negative 8, because positive 4 times negative 2 is negative 8. So we've kind of subtracted 8 from this equation. We need to also add 8 right here, so that we don't change the value of the overall equation, or else it wouldn't be a true statement. So I went ahead and added 8 here and subtracted 8 right here, technically. So that I didn't mess with any of the overall value of the equation. The next thing I want to do is factor it into the perfect square that we've been wanting to get it into. And that's what it's going to look like. Negative 2 multiplied by y minus 2 squared plus 5. That is our vertex form that we were looking for. So we can get some information from this now that it's written in this form. We probably could have got some of this before we completed the square, but just to be sure, I wanted to complete the square so that I can have the a, and you can kind of visually look at it. So anyway, I know that this is a horizontal parabola. We've got it written in vertex form. The only thing about a horizontal parabola is it can open left, get over here, and it can open right. Which way does it open? Is it going to open left or open right? Well, just by looking at the equation, our a value, which is negative 2, right here. Our A is -2, as you can see. That tells us that because A is less than 0, therefore it opens left. So go ahead, take this off. We know we've got a horizontal parabola written in standard form or vertex form that opens on the left. Our A value is -2. That tells us that it opens left. We can get some more information as well. We want to go ahead, like I said, we've got our horizontal parabola. We've got this. We've got that. But we don't know where it goes. You know, is it where at in the coordinate plane does that parabola go? Well, let's go ahead and start with a point we know, and that's going to be our vertex. To get the vertex, we're going to need H and K. Our H and our K, or our H and our K. So we've got K equals 2, H equals 5. So what that tells us right there, our vertex is going to be at the point H comma K. So obviously our H is the K value. It's not -K, it's this, K. So I got that confused at first, so just watch out for that. And there is the point of our vertex. Right here, it is 5, 2. Don't worry, we'll write this a little bit more neater. We're just kind of getting a general understanding of what's going on. Now we kind of have a point. We know that it's somewhere, you know, something like that. It's 5 over and 2 up. It's not, my drawing isn't accurate, but we see where we're going with this. Now we kind of have an idea of where it's placed on the coordinate plane. We also got some more information here. We know that C equals 1 over 4A. 1 over 4A. So our A value is -2. So 1 over 4 times A, or 4 times -2, is going to be 1/8. So our C value equals -1/8. And the reason why we wanted that is because this value right here, it's a little hard to see, I know. We want to get the focus and we want to get the directrix. The focus is going to be a point inside of the parabola, or in this case, to the left. Our directrix is going to be a line to the right of the parabola. The distance between the vertex and the directrix is 1 C value. Also, or likewise, the distance between the vertex right there and the focus is also C. So in total we have 2 C values right here. So to simplify all that, what I just said, I needed to find C so that I know where the location of the focus is, which is 1/8 to the left, and also the location of the directrix, which is 1/8 to the right. And to do that, all I gotta do is use these coordinates of the vertex, 5, 2, and I need to subtract 1/8 from the x value to go left. So 5 minus 1/8 gives us 4 7/8. So right there, we know our focus is 4 7/8, comma 2. The y value didn't change, just the x value, our left and right horizontal values. The other value we can get from this is going to be our directrix right here. We'll neaten this up here in a minute, just to give you and me an idea. This is what we want to do, is kind of a little rough draft here. So anyway, our directrix is 1/8, or a C, to the right. So 5 plus 1/8 gives us 5 1/8. So our directrix is going to be a line, and a line is the equation, not a point on the plane. So we're going to write an equation is x equals 5 1/8. There's our directrix. Before we go any further, I want to go ahead and clean the board, neaten it up, and we're going to go ahead and start drawing this a little better so we can see what's going on. We want to get some points. This is real rough, real general. Let's clean this up, and let's go from there. Alright, so I've cleaned up the board a little bit. As you can see, I've kind of moved all the stuff to the side because we're on to the graphing portion of this. So we've got our point right here, our vertex, HK, or rather 5, 2. And we know it's a horizontal parabola. There's some other things we know as well. Being that it's a horizontal parabola, we also have a horizontal axis of symmetry, which runs along this line right here. Something like that. The other thing we know is our directrix is going to be 1/8 to the right, as I was explaining just a couple seconds ago. So our C value is 1/8, and this is our vertex. Our vertex is at the point 5, 2. So let me write that here. That's where our vertex is, 5 over and 2 up. So our directrix is going to be vertical, and it's going to be at the line where x equals 5, and that's right here. So let me do that right quick. And that just keeps going, as does the axis of symmetry. So we've got our vertex, we've got our directrix, we've also got our axis of symmetry. We know it opens left, so it kind of got this shape, but we don't know, is it real skinny? Is it real wide? Well, let's look at what we got. We need to go ahead and see if we can figure out our x and y intercepts. That's going to really give us some points where we can start to really finite and see where this is going to go. So to get our x-intercepts, the first thing we're going to do is set y to 0. So I'm going to be using this, our vertex form of the equation. This is what we started with. I'm going to be using this, and I'm going to set the y to 0 using the same exact equation. Alright, so x equals -2 multiplied by 0 minus 2 squared plus 5. Now, 0 minus 2 squared, or -2 squared, is positive 4. So, x equals -2 times positive 4 plus 5. This is real simple. That gives us x equals -3. I don't have tape there, so we get x equals -3. Thus, our x-intercept is at -3, 0. So I'm going to go ahead and put a point right here at -3, 0. Now we have our vertex and an x-intercept. So we've kind of got the bottom portion of this. It's going to kind of come down like that, but where does the upper portion of the parabola go? Let's get to our, and that's by the way, that's our only x-intercept. It only crosses right there. We're probably going to have some y-intercepts, maybe too, but let's check it out. To get our y-intercepts, we need to set our x to 0. So, using the exact same equation, again, I'm going to set this x to 0, or, yeah, that's what I'm going to do. So, 0 equals -2 multiplied by y minus 2 squared plus 5. With that, I'm going to go ahead and subtract 5 and move it to this side. So I'm going to subtract 5 on both sides, basically, but really what I'm doing in my brain is I'm just moving that 5 over here. Mathematically, I'm subtracting 5 from both sides, and that's what we end up with. -5 equals 2, or -2 times y minus 2 squared. The next step we want to do is go ahead and divide both sides by -2. Because, as you see, I'm trying to get the y-intercept, so I need y by itself. And there we have it. I divided by -2 on both sides, and that gave us 5/2 equals y minus 2 squared. The next step we need to take is we need to remove that exponent, and to do that we need to take the square root of both sides. So let's do it. There we go. We got y minus 2 equals plus or minus the square root of 5/2. The reason why it's plus or minus, because it can have a negative or positive result. So when I rewrite this well, not rewriting it yet, when I'm going to go ahead and add 2 to both sides now, so that I can get the y by itself. Adding 2 to this side will remove the 2, and adding 2 to this side it's going to look like this. Y equals 2 plus or minus 5 halves. So that gives us y equals 2 minus the square root of 5 over 2, and also y equals 2 plus the square root of 5 halves, or 5 over 2. So now that we've got a couple more points, we can go ahead and add those. So 2 minus 5 halves is just a little bit more than 3 and a half. Oops, let me use a different color. It's a little bit more than 3 and a half. It's like 3.68. And so it's right around that area. And then 2 minus 5 halves is just a little bit less than 0.5 or 1 half. So it kind of goes right there. So you really have a really clear picture of what's going on here. Parabola is real skinny, not wide. We wasn't sure at the beginning. Maybe this was real high, maybe it was real low. Now we know. We got our axis of symmetry, and using our axis of symmetry, we can actually find another point. We've got 4 points up there right now. Let's go ahead and make it 5 points, just to make it a little more accurate. And we'll use the axis of symmetry to do that. So right here, we're at -3, 0, and this is actually our x-intercept. If I use the axis of symmetry and kind of flip it like that, we'll get -3, and then our y value will be 4. So we'll have another point right about here. And that'll be -3, 4. There we go. So we've got about 5 points up there. I just picked 5 just for no reason. 1, 2, 3, 4, 5. Yep, okay. And let's go ahead and draw this thing and see what we end up with. There we go. And got our points labeled. It's really hard to write that in here. I'll go ahead and just visually point you towards it. This point is going to be 0, 2 plus 5 over 2. And this point right here is 0, 2 minus 5, square root of 5 halves. I could write it there, but it'd just be more harm than good. So with that being said, we've only got a couple things left to do. I know this is rather lengthy. Our domain. Let's think about our domain. Our domain is our x values, and so it looks like we go from -infinity all the way over there. Let's go ahead and write that right now. So our domain starts at -infinity, and we want to use a parentheses for that because it's not technically a point that we're using. It just goes on and on. So -infinity, comma. Now how far over does it go? It goes over here and it stops right at 5. And with this, we're going to use a bracket because it's included it's a point on our parabola. We include it, so we put the parentheses to show that. For our range, our y values, looks like we go from -infinity all the way to infinity and beyond. So we've got -infinity to infinity. And there you have it. Thanks for watching.